Hello, my amazing Algebra Half students. This is Mrs. A, and I love math. Today we're talking about Lesson 40 in our blue books, and this is equivalent equations and the addition and subtraction rule. Now, the addition and subtraction rule is just the same thing as the addition property of equality that I talked about in the last lesson, and that one said that we could, we could add or subtract the same amount from both sides of the equation. As long as we did the same thing to the left and right sides, we were okay. We were following the rules of algebra. And remember, I told you about my teacher, Mrs. Almond, who would say that what's good for the left side is good for the right side. What's good for the goose is good for the gander. And she is long gone to be with the Lord now, but she was my favorite teacher when I was young. And she taught me in high school. Okay, so here we have a rule. Equivalent equations have the same solution. So here I have an equation that just says x is 6. So x is 6. Over here I have an equation that says x plus 3 is 9. Well, if I take away 3 and take away 3, then x is 6, isn't it? Since x is 6 and x plus 3 is 9, both have the solution of 6. These two are equivalent equations. So now let's go work on some equivalent equations of our own. Before I do that, let's look at the addition-subtraction rule from your book. The same number can be added to both sides of an equation without changing the solution to the equation. The same number can be subtracted from both sides of an equation without changing the solution to the equation. So here they are talking about the addition-subtraction rule, which in many books is called the addition property of equality. And it applies to both addition and subtraction because subtraction is simply addition of the opposite. Okay, so here we have our first two examples that look very similar. X minus 3 is 7, x plus 3 is 7. But they are not equivalent equations because they don't have the same solution. All right, so on the left, remember on the top one, remember we're always trying to get x by itself. So we want to get rid of the negative 3, so we will add a 3 and add a 3 to the other side. So we end up with x, cancel these, equals 10. And to check and make sure that 10 is indeed the solution, we plug the 10 in where the x was. 10 take away 3 is 7, and that is correct. So we've got the right answer. Okay, now we would say, and we would be true, that x minus 3 is 10 and x equals 10 are equivalent equations. Look at this one. All right, we've got x plus 3 is 7, but we want x all by itself. So we're going to subtract a 3 and subtract a 3 from both sides. So now we have x, the 3's cancel, and 7 minus 3 is 4, and x equals 4. So we plug the 4 back in here, and we get 4 plus 3 is 7, which is true, and x plus 3 equals 7, and x equals 4 are equivalent equations. Here we have one with some fractions. This is example 3 in our textbook. So now we need to get rid of the 3/4 because we want the x by itself. So we will subtract 3/4, and then over here we will subtract 3/4. Okay, so now we get x equals, because this goes out, and we have 9/11 minus 3/4, and we have a tiny problem. We cannot subtract, unlike denominator fractions, right? So we're going to have to change both of these, aren't we? We're going to have to go to 44 for the denominator. So I'm going to multiply the first fraction by 4 over 4, because I know that 11 needs a 4 to be its partner in multiplication to get to 44. Okay, and then over here, I'm going to multiply by 11 over 11 to get a new fraction over 44. So let's see what our fractions are. We always multiply by 1 because then we don't change the number, we just change its form. We can multiply or divide by 1 and nothing changes. Okay, so we end up with 36 over 44 minus 33 over 44, and the answer to x is going to be 36 minus 33 is 3 over 44. Ha, don't you love fractions? Okay, so now we haven't checked this answer, so I'm going to get a different colored pen and go back and check this answer, because we always want to check it back into the original equation. So here we go. We're going to take the 3 over 44 and we're going to plug it in right here. 3 over 44. Okay, so we have 3 over 44 plus 3/4 is 9/11. Okay, so let's rewrite it with the fractions that are all over 44. So could we multiply this one by 11 over 11? So we'll multiply by 11 over 11. And now this one will be over 44, won't it? And then we're going to multiply this one by 4 over 4. And we'll see if it all comes out okay. All right. So the 3 over 44. And then this one is going to be 33 over 44. So 3 plus 33 is 36 over 44 on the left, and then over here on the right we have 36 over 44. And it does work, doesn't it? Just takes a little bit more work with the fractions there. So let's come back with another example. Okay, another one with fractions. Maybe a little bit easier fractions though, because 5 goes into 10, right? So we're going to start by trying to get our x by itself. So we're going to, since it's subtracted already, we're going to add a 3/5, and then over here on the other side, we're going to add a 3/5. So we bring down our x. These are going to cancel, and then we're going to get 2/10 plus 3/5. Okay, well, they both go into 10, so let's just change this one. We're going to multiply the 3/5 by 2 over 2, which is 1. It doesn't change anything, and we're going to get x is 2/10 plus 6/10 is 8/10, but 8/10 will simplify. Divide by 2 on the top and divide by 2 on the bottom, which is 1. We end up with 4/5. Okay, so now we need to go back to the beginning of the problem and check to see if 4/5 is going to make the equation true. So up here, instead of my x, I'm going to put 4/5 in black. And 4/5 take away 3/5 is 1/5. So we have 1/5 on the left and we have 2/10 on the right. But if we multiply 1/5 by 2 over 2, we do get 2/10, don't we? So the 4/5 made the original equation true, therefore 4/5 is a solution. And let's go back now and just refresh. Remember, we started with this equation, and then we wound up with this equation, but since this equation and this equation had the same solution, these were equivalent equations. And then finally, we did a little bit more work, and we got x is equal to 4/5, which is another equivalent equation. So when we are solving our equations, we're solving them by finding simpler and simpler equivalent equations until we finally get the simplest one, x equals 4/5 in this case. Okay, so here we're doing our practices, and this is your A and B practice, and those are pretty simple. So I put both of them on the same board, so pause your video. Okay, hopefully you did that. So now a plus 4 is 6. A is our variable. Our variable can be anything. So a is in the same spot that x was before. No big deal. We're trying to get a by itself. So since we have a plus 4 we want to get rid of, we minus a 4 on both sides. And then we end up with a equals, this goes out, and 6 minus 4 is 2. So let's check and see if 2 is a true solution. We go back up here, we plug in the 2. 2 plus 4 is 6. It makes it true. So 2 is the solution, and a plus 4 is 6, and a equals 2 are equivalent equations. Let's look down at this one. X minus 2 is 4. So we want to get x by itself. So we will add 2 and add 2 to both sides of the equation. This is going to cancel. We get x equals 6. Let's check and see, is 6 a true solution? We plug in 6 here where the x was. 6 take away 2 is 4. Therefore, it is true, and 6 is a solution. And now we can say that x minus 2 equals 4 and x equals 6 are equivalent equations. Okay, here is your third example. So copy it down and pause your video. Okay, so now we're going to have to get rid of the 1/2 because we want the x by itself. So minus 1/2 and minus 1/2 on the right-hand side. This cancels. X is 3/4 minus 1/2, but we need like denominators. Since the 1/2, the 2 goes into the 4, let's just multiply this one by 1 in the form of 2 over 2. Okay, so now we end up with 3 over 4 minus 2 over 4 is 1 over 4. So x is 1 over 4 should be our answer, but let's plug it back in. So let's go back up. 1 over 4 plus 1/2 equals 3/4. But we know that 1/2 is 2/4. So 1/4 plus 2/4 is 3/4. And this is a true solution. So x plus 1/2 is 3/4 and x is 1/4, x is 1/4, are equivalent equations. And this is your last practice problem. So pause your video. All right, this one is not going to be too hard either because 3 goes into 12 evenly. So we're going to add a 1/3 to get our x by itself, and we must do the same thing to the other side. So then this is going to cancel, and we get x on the left, and we get 11/12 plus 1/3 on the right. But 1/3, we're going to multiply the 1/3 by 1 in order to get a common denominator. And that form of 1 will need to be 4/4. And so we get 11/12 plus 4/12 is 15/12. Now 15/12 will simplify. Okay, we're going to go ahead and leave it in improper form, but can't we divide by 3 on the top and the bottom? So that's actually going to be 5/4, which if you were to write it as a mixed number would be 1 1/4. Okay, so we can either check it as the improper fraction or the mixed number. We'll just check it with the mixed number here. The improper fraction. So we're going to put a 5/4 right there. And we're going to say, okay, 5/4 minus 1/3 is 11/12. We can't really see it like that, can we? So our answer is 5/4, but when we go back to check it, we really need to check it in the form of 15/12, don't we? And then this one, we're going to have to change it to its new form, multiply it by 4 over 4, and we're going to get 15/12 minus 4/12 is 11/12, and that is true. So this first equation is equivalent with x is 5/4. And that was a lot of work, but we are done. And this is Mrs. A. and may God bless your day.